Hey everyone, my name's Courtney and I'm here with Courtney and Danica, and today we're going to be talking about our project findings for Engineering 450. So this is our presentation overview. First we'll be going over our project overview, then research questions and our original hypothesis, then our design of experiments, the testing center that we had for our test subjects, underlying data sets, methods used for analysis and demonstration, our insights and conclusions, and finally our refined hypothesis. So here's our project overview. We conducted a time study where at least 15 individuals per scenario are asked to complete a Sudoku puzzle. They will be exposed to different combinations of noise and light, and the task time and accuracy were analyzed, and we did sound and no sound, and then we varied between warm lights and colored lights. So this is our research question and original hypothesis. Do different combinations of sound and light impact workers' productivity? Our null hypothesis was that there is no effect, all combinations are the same, and our alternative hypothesis is that there is an effect. So we used design of experiments concepts to formulate our design and the experiments that we actually carried out. Our dependent variables were the time to complete the task, the independent variables were the lighting and the sound, and the control variables were the location, seating area, and the difficulty of the task.
To discuss some of those independent and control variables, our testing center had a lot to do with that. So the room layout stayed the same for every single person that came in. It was an office with a desk that they could do their task on, and then lights positioned around the room. The task was for them to complete a Sudoku. The Sudoku was the same Sudoku for every single participant. So that was a control variable that stayed the same. And then the time to complete and the percentage to complete were the output variables. And the time to complete, we gave participants up to 10 minutes. If they hit 10 minutes, we would cut them off and say that they were done. And the percentage complete is how many squares that they accurately filled in. So there were 36 squares that they needed to fill in, and however many right that they got divided by 36 was their percentage. And then the things that changed were the sound that they were listening to and the lights that they were seeing. So they either had no sound or they had an ambient traffic sound. And the reason that it's important to say that it's an ambient traffic sound is that this is like a calming sound. It's not necessarily the annoying traffic sound that you would normally listen to. And then for the lights, we had a blue, violet colored light and then a warm light. To explain the data set that we recorded and all the information that we took from our participants, we have this chart here that shows the sound and the light. So these are the 4 different scenarios that participants could have been subjected to. So the sound could have been a yes or a no, and then the lights are either the white or the C stands for colored. Other things that we recorded from our participants were their gender, their age, and then their familiarity with Sudoku. So we kind of explained it to them as if you've never played before or if you need to have a refresh on how to do it, that'd be like a 1. A 2 is I know how to do it, but I haven't done it in a long time, or I do it, very rarely on occasion. 3 is I'm average skill, 4 is I'm really good, and 5 would be I'm an expert, I play every day.
So once we had all of that data, we decided to put it in a fit model, and here are all of our inputs with our outputs of our time to complete and also our percentage complete. So once we ran that test, we saw our points of interest over here. We saw that a low familiarity with Sudoku was a significant value. And then also down here, if they had no sound and they had color lights, that was also proven to be significant. And then also our last one here was a low familiarity with no sound and also with colored lights was also significant. But when we first were doing this, we saw that there was a little bit of biased data there because of the level 5 points, so we removed those and then ran these tests.
So as Courtney just said in the previous slide, we removed all of the data points where the subject indicated that they were a level 5 familiarity with Sudoku. So here this is a control chart showing the other 4 familiarities. We found it very interesting because 1 and 4 seem to be much more accurate in what the subjects were indicating their familiarity was. There's a few outliers, but when you compare that to 2 and 3, you can see that the individuals were not very accurate saying what their skill level was at Sudoku. So that kind of is going to show some effects in our data.
This is a linear fit model just showing the age of our participants versus the time it took them to complete. And we did not expect age to be a strong factor here, so this is no surprise for us that this fit isn't very good. This slide is just here to show that age was not necessarily a participating factor, but also that the majority of our participants were in their low 20s because we were doing this on a college campus. We do have a couple other ages in there, but the majority were around 20. This is a one-way ANOVA showing the time to complete the Sudoku by each scenario. So at the bottom here, the scenarios 1, 2, 3, and 4. 1 is if there was no sound and if there was white light. 2 is if there was the ambient traffic sound and white light. 3 is no sound and the purple lighting. 4 is yes sound and the purple lighting. So it's the scenario by how long it took the participants to complete their task. And you can see here the probability over here is pretty high, so we cannot reject our null hypothesis with this. We see that each of these 4 scenarios are pretty similar. Similarly, this is a one-way ANOVA for the percent to complete by each scenario. So the scenarios down here are the same, but this is the percent that they completed of the task correctly. Here you can see that there's a little bit more difference, especially in scenario 3. But once again, there's not enough significance to reject our null hypothesis.
Lastly, in case anyone was curious about the distribution of our data, this shows the distribution for both the familiarity and the gender of all of our participants. For the familiarity, we know that 2 and 3 were not necessarily super accurate, but we demonstrated that in a previous slide. And then for the gender, we see that more participants are male than female, but this is kind of obvious because we were studying this in a university engineering department, so that's not so much of a surprise that there's more males than females. So then for the results of our testing, this is done without the data from the level 5 familiarity. And so we can see here, group 1, which is the no sound with white lights, had 19 participants with an average time of 6 minutes and 4 seconds, and average completion was 90%. With group 2, which is the sound and white lights, they had 16 participants and an average time of 6 minutes and 25 seconds with 97% complete. Group 3 being the no sound and purple lights, they had 15 number of participants and an average time of 6 minutes and 43 seconds with 87% complete. And then finally group 4 was the group with sound and purple lights. They had 16 people participating in that and had an average time of 6 minutes and 12 seconds with 91% complete. So in total we had 66 participants with an average times of 6 minutes and 20 seconds and 91% complete. So when they had sound, the percent complete was higher than without sound, but it wasn't enough to be statistically significant. And so as we showed in our fit model, group 3 was the worst performing overall.
That brings us to our insights and conclusion for this entire project. The factors that had impact were if the scenario was no sound and colored lights. Overall, that created a slower and less accurate group of people. Also, if people had really low familiarity with Sudoku, with the task, they also were a much slower and less accurate. So our kind of insights into this is, while the sound doesn't seem to really impact it a whole ton, the colored lights might slow people down, but it doesn't really seem to have a huge impact. The biggest impact, honestly, was the low familiarity. So our future works should not accept people that have that low familiarity. Maybe we choose a task that's a little bit more easy for the average person to complete. And then we also would like to, if we could do this again, do it with more random subjects. We did try to have more of a random selection by posting that we were doing this study onto social media to try and get people from other departments to come and participate. But the age of our participants was pretty much the same. And then the type of people was very similar because we were doing it in a university engineering department. Our refined hypothesis then is the same as the original, with the null hypothesis being that there is no difference between the scenarios, and our alternative hypothesis being that there is a difference between the scenarios. while our fit model did indicate that level 3 scenario was slower, in our other models we could see that there wasn't really enough statistical significance to completely reject the null hypothesis. So that is our project for 450. We hope you enjoyed, and those were our results.